In this video, we're going to understand what it means for a function to be one-to-one. We'll be able to determine whether or not a function is one-to-one using the horizontal line test, and we'll be able to determine whether or not a function is one-to-one using algebraic techniques, okay? And it's important to note that these two learning outcomes will be in the first part of this video, part 1, and this last learning outcome over here will be a part of part 2 of the video, okay? So let's get started with one-to-one functions. Let's talk about the generic idea. Now, if you recall, a function is just a rule that you give it an input value and it's going to give you an output value, right? And a function is one-to-one when there is a unique output value for each and every input value, okay? And in other words, if two different input values that you put into the function equal the same output, then the function is not one-to-one. Now, this may not make much sense, but I'll go through a few examples and it'll be a lot clearer. It'll be a better image to see. So f of x, let's say f of x is equal to 3x plus 1, okay? Just a basic linear function. Now, if we started substituting a bunch of x values, right? So let's say we substitute f of negative 1, f of 0, and f of 1. Then f of negative 1 is just 3 negative 1 plus 1, which is equal to negative 2. F of 0 is just equal to 3, 0 plus 1, which is equal to 1. And f of 1 is just equal to 3, 1 plus 1, which is equal to 4. Okay? Now it's important to note, I'll just write this 1 better. It's important to note that these values are all input values. So we put these values into this function over here. That's why they're called input values, right? And these answers that we got over here, let me just write it in yellow. These answers that we got are called output values, okay? This just means these are the answer. All of these numbers, negative 2, 1, and 4, are output values in this case, okay? Now, a function is one-to-one when each and every single input value, every different input value has its own unique output value. And you can see over here that all of these input values are different, right? Negative 1, 0, and 1 are all different numbers. And their output values are also unique to them. So negative 2, 1, and 4, their output values are also different numbers. So that means for every input value, we have its own unique output value. And when that scenario takes place, we call the function one-to-one. Therefore, f of x is equal to 3x plus 1 is 1 to 1. Okay, now let's look at another example. This is f of x is equal to x squared. Now, let's do the same thing. Let's substitute some x values. Now, f of negative 1, we'll do f of negative 1, f of 0, and f of 1, okay? F of negative 1 is just negative 1 squared, which is equal to 1. F of 0 is 0 squared, which is also equal to 0. And f of 1 is 1 squared, and this is equal to 1. Now, have a look. All of these input values are different, right? Negative 1 is different to 0, 0 is different to 1. All of these numbers are different. However, when we are to consider their output values, these two numbers are the same, right? 1 and 1. Like, they're both positive 1. And despite the input values being different, the output is still the same. So this is when we call a function not one-to-one. Therefore, f of x is equal to x squared is not 1 to 1. Okay? Now, this is the generic idea of it. Now, there's different ways to calculating whether it's one-to-one or not. So if we want to calculate if a function is one-to-one or not, there's two ways. Number one is horizontal line test. And number two is algebraic methods. Like I said earlier, we're going to focus on horizontal line test for this video, and part 2 is going to go through the algebraic part of it. Either way, both of these work in determining whether they're one-to-one or not, but yes, for simplicity's sake, we'll do this one first. So horizontal line test, okay? it's very simple and intuitive and like an easy technique. So basically, if you're given a function f of x and you want to determine whether it's um, one to one or not one to one, your first step is to sketch the graph, and then number two is draw a horizontal line across f of x. Now I'll show you what I mean. So we want to determine whether these graphs, these functions are one to one or not. Okay. Now let's see. We have f of x is equal to e to the x. We're going to draw a horizontal line across, like that. Well, let's just draw a straight line. And we have one point of intersection, right? This is where the line intersects with the graph, the function. Okay. Point. Let me just write that down. Point of intersection. And if we have one point of intersection, then the function, if we've only got one point of intersection, then the function is one to one. If we've got more than one point of intersection, then it's not one to one. So we write only one point of intersection. Therefore, f of x equals e to the x is 1 to 1. Okay, it's as simple as that. Next question, we have f of x is equal to sine x, and we have the graph down. We're going to draw a horizontal line through it, and as we can see over here, the graph intersects with a line at this point, and this point. 3 points of intersection. Let's just write it in white. 3 points of intersection. Therefore, f of x equals sine x, not 1 to 1. Okay, it's as simple as that. Our next example is f of x is equal to x squared. Now we're going to do the same thing. We're going to draw a horizontal line. And we've got 2 points of intersection, one over here and one over here. And anything more than one point of intersection, as you know, is not one to one. So we write 2 points of intersection, therefore not 1 to 1. Okay, our next question is y is equal to x. It's just a regular linear function. We're going to take this color and we're going to draw a line through it. And this is our point of intersection. We've only got one point of intersection. Only one point of intersection. Therefore, let's write with this one. Therefore, y equals x is 1 to 1. So essentially, once we draw our line through, if we have one point of intersection, if we've only got one point of intersection, then the function is 1 to 1. If we've got more than one point of intersection, such as 1, 2, 3, any more than one, that means the function is not 1 to 1. Okay, it's a very simple process. It's very easy, but in the next video, part 2, we're going to go through the algebraic method.